Okay. I think this is up and running, so I'm a little tired. It's getting a little, that's only 8 o'clock, but I'm not going to spend too long on this today. This is probably the last chance, or maybe the second last chance I'll have to work on this before I go away for a week. Yeah, well, anyway. So let me reset this. And the problem is as follows. Let's say I put down a junction. I wire it up like this, so now both nets are connected together. And I erase this. This violates one of my post conditions. So there is only one net in the list of global nets, but this junction object right here seems to be pointing to 2 nets, and the second one is not in the global nets list, or maybe this is the one that's not in the global nets list. Anyway, there's a lot of stuff wrong right now, and I basically just need to understand how this happened, and yeah, so I tried looking at this log, so let me, excuse me. Okay. So let me reset this. Put down this, that. I don't want too much in here. So put down this, do that. Now I'm gonna go into the log here and just add a separator. And let's erase this. Now let's take a look at the log. I was trying to look at this earlier, and I'm thinking that I need to add some more log statements into DFS. Yeah. So, let me think about this. Now, when I erase here, I first clear the grid square, and then what I do is I check all of the neighbors. I do a DFS on all of the neighbors of this square. For each one, I delete the net that matches everything that gets seen, and then I remake it and push it back into the nets list. And then once I've done that, I do all the other neighbors. So what will happen here is the neighbor to the right has nothing, the neighbor to the bottom has nothing, then we check this one, and that's, I believe, where this log from DFS begins. So found neighbor, that's to the left. So we start the DFS at coordinates. Okay, so this junction is at coordinate 1, 1, so we start at 1, 2. We start at 1, 2, excuse me. It hits our special case where the neighbor is a junction, and then we actually test the port of the junction, and we go, oh, that port is connected to us. So we keep DFSing. So then what we do is we traverse over to the square that has the junction on it, which is 1, 1. And then we run a DFS from there. We first check to the right, and we do see a net to the right. Now, because the junction was connected to itself, then to the right of the junction appears to be part of this net. And so it gets added to the list over at 2, 1. Now this is strange. I guess somehow we end up back at 1, 2. Okay, so first of all, I think it's important for us to not connect junctions to themselves. Because that is just going to confuse DFS. Like, we could add a case in DFS to detect that, but it would be better if well, would it be better? I was about to say it would be better if a junction just couldn't connect to itself. Like if you tried to do it, it would say, no, I will not do that. But let's not forget that there are there are arbitrarily complicated ways to connect a junction to itself. Like you could do this, 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 and this. Then you can come over here and do this and this and this. And then you're just doing your thing, drawing your wires, and either by accident or on purpose you do that. And now they're connected together, right? So there's only one net, only one junction. If I erase this, we hit our post condition. So, oh my goodness, and then everything died. Where the heck? Grid. This is in the post condition. Oh, where did I get K from? KV impairs grid. Oh, wait a minute. Oh, GX. Oh, this should be GW. Whoops. But yeah, so, okay. Just out of curiosity, well, no, never mind. I was about to say I'd like to know how much of the runtime is taken up by the post condition check, but I don't really care about that right now. So, let's go back to the simple case for a second. We erase this. What happens if I set this to 1? Yeah, okay, so this is setting the unlisted net to 1, and because the junction, yeah, so if I keep drawing wires from this unlisted net, oh my. Yeah, okay, well, I feel like I'm not getting anywhere. I feel like I am not making progress right now. If we do this, and what should happen here? Well, I think what should happen is when we do the DFS, we shouldn't keep following the junction. We should keep following the junction, but only in the direction that we approached it from. See what I mean? That's what should happen intuitively. I still need to understand the way in which we get our post-condition violations, so let me keep thinking about it here. We hit that. Now, is this little bit of wire, oops, I didn't mean to do that. Is that little tiny, so is this little wire stub here actually connected? It is. So we have a net that is disconnected. Now, if DFS didn't jump the wrong direction through a port, or through a junction, I mean, then this wouldn't happen. We'll probably get it to crash if we keep screwing around with it here, but anyway. So that would fix that problem where we have a net that's disconnected. where we just have like phantom connections. Now I still need to understand why we have a net that exists but that isn't in the, okay, we need to add some more logs to DFS, right? So, add C let's also try to do this. Whoops. To chord list. So this is a base case kind of thing here. So I'll just mark this with a different, like, you know, character. Otherwise, if the grid type is junction, for P, check if either net is equal to N. Okay, I think it is, well, I think we need to support the case where both nets of the junction are the same. Man, I feel like I'm not making any progress. Let's add some more log statements. DFS at blah. Whoops. And here we will do add NL. Also, C is not correct up here. Come to think of it, it's L. Excuse me. I'll deal with this later. Otherwise, if it is a gate, you know, let's just go ahead and do all of it. Whoops. Oh my goodness. I hit something. I just want to keep this, I mean, a bunch of different branches use it. I'm not really care about optimizing right now, so. Neighbor Pinum is net. Going here. Neighbor Pinum is gate. Let's turn on the asserts. I don't remember what that is, but we may as well turn it on. What happened? Oh my goodness. So now here we are adding something. I'll just say add to port list. I don't necessarily, I can add more debug info later if I really need it. Neighbors junction. Okay, so we already have junction is connected, keep searching. Now here is one issue we need to fix, not the only one, which is that when we're doing DFS and we're following a junction, we shouldn't follow all its neighbors. I don't want to add another parameter to this function. We could man. I mean, recursing on DFS is definitely what we want. The rules for what is the neighbor are different. The rules for what is a neighbor are different. There's got to be a clean way to do this. It almost feels like I should re-implement DFS from scratch. I've implemented here as a recursive function. It is possible to implement DFS without recursion. I'm not really sure why we would bother to do that though. I mean, recursion is just a lot cleaner. I think yeah, it really does boil down to computing the neighbors of the node that we're on. I mean, that's just how DFS works. So how do we know when we enter DFS what neighbors to use? Idea 1. Check if the grid is a junction square. But if so, we need to know which direction we came from. It's the only way to know. I mean, what if I hid it in one of those tables? No, let's not do that. Oh, actually, one idea is to check the scene. Oh, but no, that wouldn't work in general. We could leave a trail, like a breadcrumb in the junction object. Like DFS could just write something in there. There's nothing really wrong with that solution, except it just feels a little, messy. Well, messy. We're way beyond the point of messy by now. Man, how can we do this? Maybe we could just have an optional 8th argument. How many arguments are we at? 1, 2, 3, 4, 5. An optional 7th argument, which is a neighbor mask. I don't see any other way. I don't see any other way. Yeah. It's I mean, it makes the DFS even clunkier, but yeah, I mean, let's just do it. So, I don't even know what to call this. N hint. Or N list. Another hack. If N list is given, then use N list as the neighbors to traverse. Otherwise, just check all neighbors. I mean, you got any better ideas? I certainly don't. So we will do local nlist equals nlist or neighbors. Nlist like so. Now we will have a lookup table neighbors based on junction type. So neighbors J is equal to, this is where, I mean, I'm being really, dumb about it here, but neighbors of 2, we are allowed to go up and down. So that is GW and minus GW. And the other one is 6, right? 6. We are, oh, right. Right. So based on, oh yeah, of course. So we actually need to do port 1 is equal to minus GW. Port 2, actually we can just write it like this. I mean, it's actually just the opposite of neighbors, isn't it? Just minus neighbors. Wait, maybe not. Port 1, no, this isn't even minus GW. Port 1 connects to, right. If we approach a neighbor from the right, no, if we are searching our port 1, right, that means we're approaching the neighbor from the left, and so it is 1. If we are searching through our port 2, yeah, actually this is just equal to neighbors. This is just equal to neighbors. And then this number 6 is, if we are going from our port 1, then we got to go down, which is GW. If we're coming from our port 2, then we got to go to the right, which is 1. If we're coming from our port 3, then we got to go up, which is minus GW, and then by process of elimination it has to be -1. Only used in DFS. See there for how we use it. So then what we will do is go in here to DFS. In here into the junction case. We've got our pnum. Get list of neighbors to search, but the list is only going to have 1 element. I mean, if we had vs, it might have more, but anyway. Local n list is equal to the table created by the single element that we get by looking up neighbors j of O dot parents dot, what did I call that? JT. Man, my names are all over the place. JT of pnum. And here we will do n list, and now for our sanity, for, well, log num list equals, actually let's just assert. Assert. And list 1 Okay. Down a junction, put down a wire going around. That looks like a result. No post conditions. Yeah. No post conditions. What if we go kind of crazy with it here? Just one net. We add a junction. We wire it up. Then we try to break it. Oh man. Man, I thought we had it. Yeah, this case of the junction having the same net twice inside of it, we just need to... I don't think the right solution is to prevent it at all costs, because no matter what the user does, they're going to do it by accident at some point. And I think supporting it is the right move. So we just have a couple of corner cases here and there where we have to deal with the fact, especially when we're erasing wires, that seems to be where things go wrong. We just need to deal with the fact that a junction could have the same net twice, and we need to do the right thing. Yeah, I think the only way we can do this is with the erase square logic, because the only way you would change that the junction connects back to itself is the only way that could possibly change is when you're erasing something. So we only need to deal with that case in erase square. So let's, well, think about it. Okay, let's not do this because it's filling the log with useless information. Well, it's not useless, but you know. So, no. I see. So although I fixed this case where it doesn't actually connect, if I were to do this, I would still have the same problem, right? So if I erase this now, oh boy. Oh my goodness, we have a lot of problems. This is an unlisted net, apparently. This is an unlisted net, apparently. Actually, all of these three are an unlisted net. Apart from that unlisted net, we still have two left, which actually are correct. Actually. Well, maybe. Yeah, actually, these two nets are correct. So it's this up here, which went wrong. So when we erased here, okay, I want to see the DFS for this. So we have this guy, wire it up. We have this guy, wire it up. Okay, now let's put in a separator into a log, just a whole bunch of them. Erase that and read what's going on inside DFS and see if we can make sense of it. Okay, so what's going on here? Okay, 1, 2 is the first place we searched. So we searched to the right, got nothing, went down, got nothing, went to the left. And that was the first time we called DFS, so it created a new fresh table for the return tables. And it was like, oh, well, while I'm doing that, let me actually check this first square to see if I should add it, and it does add it, and that's fine. So that's why we have this hourglass message in the log. Then we actually start doing the DFS there. Second neighbor is a junction. Junction is connected, keep DFSing. We go to the junction, and neighbor 4 is net. So we add 1, 2 to the coord list, and then we actually go to 1, 2, right? So we add the neighbor, and then we DFS from the neighbor. And then for some reason, this DFS at 1, 2 just stops dead. Oh boy. And what was 1, 2 again? 0, 1. 0, 1, 2. Oh, that's because it was seen. Wait. Neighbor 4 is... I just need to see this. So we check all of the neighbors. If not seen, then we go in here. If it is equal, neighbor 4 is net. Add it to the list. DFS from there. Now here's something bizarre. Neighbor 4 should go up, right? So why is it that the next DFS we call neighbor 4 is net, add to the list, and then call into DFS? So in what universe is 1, 2, neighbor 4 of 1, 1? That doesn't make sense. That doesn't make sense. And where do we get this neighbor number? Pinum lut of D. Let me read the description of Pinum lut for a second. Given the gate linear coordinate minus the neighbor, so current minus neighbor, returns what port number it is. So if I am sitting at somewhere in the coordinate and I'm checking my neighbor, say to the left of me, my linear coordinate minus my neighbor's linear coordinate is +1, and that is port 3, and that's correct. And if I am below my neighbor, I do me minus my neighbor, I get plus GW, that's neighbor 4, that's correct. So I think, oh, I see. I think that problem is probably with my Pinum lut. I think this is backwards maybe. So where do I look up this neighbor's J here? How do I use it? is J. I get the junction type. I take the port number. Now this is correct. This P number is correct. So if I go in here, the neighbors I'm allowed to check are, okay, well, let's do them one by one. So if from me to my neighbor, return port 1, I am approaching my neighbor from the left. So that means that the allowable neighbor is to the right. If I approach my neighbor from port 2, that means I approach it from the top, which means that the allowable neighbor is to the bottom. I don't get the problem here. It's got to be this. Same thing. Which shouldn't be surprising. We are doing a DFS at 1-1. Neighbor 4 is a net. Neighbor 2 is a junction. DFS at 1-1 and our allowable neighbors. Our allowable neighbors is just 4. Oh, I get it. I see the problem. Wait, no I don't. I was about to say, I thought the problem for a second there was that I was putting port numbers instead of coordinate updates in endList, but that's not true. I am putting coordinate updates in endList. What? Okay. I guess I didn't need it. And also, I think by now I need to do two things. I need this a little bigger so I can see. And also, let's put this in our button P mode so we don't click a whole bunch of extra times by accident. It's a lot less convenient in button P mode. I went to a lot of trouble to do the interface and all that. Okay, everything's fine so far. Then we go down here and erase it. Everything goes haywire. Okay, I need more space in the log. Which is kind of annoying, but whatever. We need it. Put in some separators. Erase. Look at the log. Found neighbor, we have our base case there where we added 1 and 2 to the coordinate list. Did a DFS. We checked all the neighbors. neighbor 2 is junction. Wait a second. It's self minus neighbor. I think maybe the issue is I need to do minus D inside penumlet. I don't think this will fix it, but it'll certainly change stuff. Not sure how that was working before. Oh yeah, because it didn't matter what order we did them in, I guess, maybe. Add some separators. And same problem, which I guess is a relief in a way. Neighbor 2 is junction. Where do we even get that neighbor 2 from? Penum is, we look up D. We try to the right, get nothing. We try down, get nothing. Now when we try to the left, we should get something. That's neighbor 3 to the left. Then we try, no. Okay, I get it. We erase that square, but we start the DFS on its neighbor. Right, so on that neighbor, we do actually go all the way around. And then we go upwards, which is 129, which is correct, right? The neighbor is L plus D, which this is correct. But this penum is not correct for some reason. It should be 4. That's important because I use this penum in the JNum, or the, what did I call it? Neighbor J? Anyway, so the way you're supposed to use penumlet, it is self minus neighbor, and that gives you the port on us that points to the neighbor. Now here, neighbor is equal to self plus D. So self minus neighbor is self minus, in brackets, self plus D. So the difference is minus D. Maybe I need to save and run. I don't think that'll do anything different. Add some separators. Okay. Now erase this, same result. Now why, okay, what is going on with this penum, or penumlet? Minus GW equals 2. Is this just backwards? Given gate linear coordinate minus neighbor linear coordinate. Where it is on the, so I'm going to call this self and neighbor, and I'm going to rethink this carefully here, what port number it is on the self or on the neighbor. So if self minus neighbor is -1, then it is port 1. If self minus, and it is on the self, okay. If self minus neighbor is minus GW, that means the neighbor is underneath it, and it's port 2. If self minus neighbor is 1, then it's port 3, and if self minus neighbor GW is port 4. I mean, that's fine. So am I using it wrong in here? Why is penumlet wrong? I mean, I think I had it right the first time. I mean, I thought about it carefully the first time I wrote it. Oh, I forgot the separators, but that's okay actually. Neighbor 2. So the d being minus 129 is fine. Why is that giving us neighbor 2? If self if neighbor is self plus 129, right? Am I just losing? Can I not just do? Can I just not do algebra? Like, if neighbor is equal to self minus 129, that means the neighbor is above us. It means also that self minus neighbor is positive 129. Did I do the? Hold on. I need to write down. I need to write down the math here. We have neighbor is equal to self plus some difference, right? So that means that neighbor minus self. Oh wait, neighbor minus self, not self minus neighbor. Given, no, it is self minus neighbor. So given self minus neighbor, self minus neighbor is equal to self minus self plus d equals minus d. So over here, it is minus d. But how come that didn't change anything when I did that? So let's put in this guy. Put in some separators, go down here, erase it, go back in here. If I plug in positive 129 into pnumlet, it should give 4. What? What? Why? Am I just doing something weird with pnum? Space in the log, don't we? Well, okay. What? Wait, how is it turning to 1 right there? What the heck is going on here? When I write neighbor Blas junction, I do neighbor peanut. Oh. Oops. Forgot to undo that there. Okay. So we don't need this anymore. We don't need that anymore. We solved that problem. So now at the very least, we should get a different result now. Not that I know what it'll be. Okay, that's different. Is it correct? Well, maybe. Didn't hit any post conditions. Let's reason about what would have happened there. So we would have checked here for DFS. We would have gone up for DFS. With our fancy neighbor stain, we would have said, oh, perfect. Check this out. Perfect. Because, check it out, right? This node was marked as seen. So we went around here, but it was marked as seen, and then we stopped. And that's okay. I don't mind that. User can fix that. I mean, like, it's not ideal because the user may have been editing some huge net that spans multiple screens and something may have gotten disconnected and they would have been like, what? But that's okay. I don't care. You know, this is a complicated enough thing, and a user who's doing something that complicated and connects a junction to itself, you know, they should be debugging, and yeah, I don't mind. And then we do here, we check the other neighbor, and we do the other leg. So is it possible for us to have an issue where we don't check the other leg? So let me see if I can think of a way that would happen. So we do this. The junction is connected to itself, right? We also have this like that. So at this particular moment, everything's fine. But see, if I erase this, it'll build a net out of this right here, right? But then all of this stuff will get dropped, I think. Yep. Yep. So how do we fix that problem? What if we don't mark junctions as seen? I mean, I know it sounds crazy, but hear me out. This might lead to an infinite loop. I have it on slow, whatever. Let's just put it back on fast mode. Oops. So far so good. Whoops. But actually so far so good. So good, I guess. Let's say we erase this. Okay. Now, what happens if we erase this? We should get 2 nets left over. And we do. I think this works. I think this works. What is this? I'm getting the phone call.